In the name of Allah, the Compassionate and the Merciful. Hello guys. Based on previous videos about analyzing of moment curvature of concrete unconfined section with defining the actual load, and which we wrote it and trying to run it in Python, you will see that with the effect of actual load or not actual load is run, and the code is available. You see in here we output the effect of actual strain based on actual load, and after running the iteration reach to ultimate strain as unconfined concrete strain capacity, and trying to bilinear the curve and finding the flexural rigidity and for elastic and plastic flexural rigidity. And you see the output is shown in here. For different outputs you will see, and also steel rebar strain and stress relations during the analysis of moment curvature, and also plotting the top fiber concrete strain and stress relations, and also moment curvature relations based on rounded analysis. So in next step we are going to define the reliability analysis based on Monte-Carlo method when we have different uncertainty conditions for our values during the analysis. So let's see at the top of this analysis. You will see that in here we have real values as a constant values. For example, for width of beam and height of beam and rebar diameters or different values. For example, concrete strain is a constant, and also for other values. But in the next step we want to run the reliability analysis and using uncertainty values with using beta probability distribution function for finding the critical values of moment curvature. For example, ultimate moment curvature, ultimate actual strain, and other values. So let's see in the code. You see in here I defined these values as the same of previous videos for calculating actual stress and moment curvature analysis. But in here we use different functions such as beta PDF, so, and Newton-Raphson for calculating the failure, the ratios, and also plotting the histogram and outputting in Excel. So in here, if we run 2000 steps with Monte-Carlo method for our simulation and calculating the actual stress, applied pressure load as a compression or tension, ultimate curvatures, ultimate moment, ultimate crack tips, and flexural rigidity of the last flexural rigidity of this result. So and for 2000 iterations, 2000 simulations for our model, you will see that in here I use the actual load with the beta PDF with the minimum and maximum as a pessimistic and optimistic with these coefficients as alpha equals to 0.5 and beta equals to 0.5, and other values you will see that it is different ranges, not a constant value for pessimistic and optimistic values, also for rebar diameters, and also for length of each layers of rebars, and also for concrete strain, and also other parameters for definition, for example, yield stress of steel rebar, or even module of elasticity of concrete steel rebar, and so on. So we run it 2000 times, and at the end we calculate the ultimate curvatures, moments, crack tips, and flexural rigidity, and applied loads. If we run 2000 times with at least 33 minutes, if you divide this value to the 60, you will see that it equals to 33 minutes, and trying to export or outputting to the Excel file and plotting the actual strain during the analysis with different variables, and also the curvature, you will see that, and also the ultimate moment and the crack tip of this analysis during the analysis for our 2000 simulation, and also flexural rigidity, you will see that in here. So in here we assume that we have the applied load during in the one section of our concrete structures, and as a mean and standard deviation. So suppose that in some sections of your concrete sections with defined values, we have some loads as a moment with the mean and standard deviations values with various numbers of these values. We want to find the failure probability and reliability index for our model. So for example, I defined it as my own value, so you can change it and you can define with your own. So if we run this code to calculate the flexural rigidity, you will see that we have two distributions functions as applied moment and resistance moment. So you will see that the applied moment is much bigger variety and very deep, and resistant moment has a lower one. So you will see that if we run this code, the flexural rigidity based on our defined values is equals to 66% for our model. So it is very high that our section based on our applied loads, it's going to be fail. So we have applied load and a resistant moment. So based on this defined value, 66%, we are going to have a failure probability that the structure sections is going to be failed. But sometimes we want to control the failure probability, so we defined percentile probability in here, and finding the maximum applied load of this structure based on probability, failure probability. So in here I defined, for example, 10% as a failure probability, and finding the reliability index, and also finding the moment applied load based on this 10% probability failure. So it shows that if we run this code, we have these values for reliability index, and also this absolute moment for maximum of this applied load. So if we increase this value, the failure is going to be up. Okay, guys? So in this analysis, we use reliability analysis with using Monte-Carlo method with different values of our variables data for different parameters for concrete properties, steel and concrete strain and stress relations, and other parameters for definition for running this analysis with using Monte-Carlo method. And at the end, I showed you that it is very simple to control your failure based on this analysis to finding the optimum applied load for your model based on this analysis. So thanks, guys. I'd be glad to know about my modeling. Please have a comment and tell me now. Bye.